Hello everybody and welcome to your Friday's fraction learning. Well done for making it through another week. So let's get started then. So the first thing I'd like you to do is to connect any of these numbers that could be classed as multiples or factors, any that have any relationship using your times table knowledge. Now be careful, there might be a huge web of connections that you can make. So I just simply want you to think about the same multiples of certain times tables or factors of those multiples. So simply connect as many as you can using your knowledge. Let me just do one for you so that you know what I'm talking about. So I know that I could connect 3 with 15, but then 3 and 15, I could also connect 5. Is there any more that I could connect on there? No, let's just go with those 3 for now. Those 3 are all related because 3 times 5 is 15. Okay, I need to see how many more of those you can make. And come on back when you've had a go at that. Once you've done that, what I'd like you then to do is to think, why has Miss Syson asked me to do this? How can multiples help us when we are comparing fractions? How is that knowledge going to help me to compare fractions? Have a little think and write a little explain about what we were doing yesterday. Why is this a really good skill for me to have? Brilliant. So hopefully you've had a go at that now. So I'm not going to go through all of those because there are lots and lots and lots of different ways that you could have done that. Just making sure that you're checking your times table knowledge. You've got your learning logs with your times tables written in, so you could just quickly have a check through your own answers. Now, why have I asked you to do this? I'm hoping that you started to realise how much multiples and knowledge of factors and multiples can help you when you are comparing. Because remember what we were doing yesterday? Do a quick rewind. We were trying to compare fractions with different denominators. And what we had to do was to ensure that they had the same denominator, because then that was easier for us to compare. Now, the way that we can get our denominators the same is by using our knowledge of multiples and the relationships between those denominators that we are working with. So hopefully you realise that and remember that from yesterday. So let's get started then. So today we are going to be comparing and ordering fractions. We're going to continue with this new learning. And why? So that we can apply our knowledge of greater than, less than, and equal to language to fractions. So that's what same what that we were doing yesterday. We're just going to have another day of practicing, and I'm going to try and challenge your brains a little bit more. Okay, so first question here then. So have a little look at this. You can see we've got a signpost, and this lovely family here are on their way on holiday by the looks of it. And this one here has got the distances in miles that they still have to go to the different places. Okay, so the first thing I want you to do before you even start to answer any of those 1A or B questions, I want you just to actually have a little look at the signpost. Okay, which of those are easier to compare and why? Which of those are going to be more difficult for you to compare and why? Okay, I just want you to simply look at them and just have a think. Which ones can I easily compare and which ones can I not easily compare? And are there any relationships that you can see there between the signs, the distances? I'm not going to say anything. Wonderful. Once you've had a little go at that and you've thought about which ones are easier and why and written those explanations in your books, you can then have a look at question 1. So the question 1A is, which is closer, the cafe or the shop? Okay, so that's 1A, the first part. So you need to look the cafe and the shop, which one is closer. And I actually want you to explain how you know. So rather than just saying the shop, I want you to explain how you know, using that mathematical language. How did you know that that one was closer than that one? Once you've done that one, same again, but this time you're looking at the beach or the castle. Okay, so once again, how did you know which one was closer? Was there any working out that you might have to do? And what knowledge did you use to know which one was further or closer, sorry. Once you've done that, we're going to have a go at B. Which is further away? So which one is the furthest away, the longest distance? The garage or the peer. Now this one, before you even start, I would like you to have a think about what is different about these distances and what are you going to have to do before you can compare them to find out which one is the furthest. So again, all about that independent thinking, those independent questions that go through your head when you're answering a question. I want you to write down all those ideas before you actually get an answer, okay? As always, proving it if you think you've done it. You can always use diagrams to either help you. So if you're finding this a bit tricky, you could use those diagrams to help you, or you could use those diagrams to check that you're working out that you have done was correct. And then use it challenge then. Could you convert these mixed numbers and improper fractions to make it easier to compare? So once you've done those questions, or if you are finding this a bit tricky, could you use your learning from a few weeks ago to convert them all so that you can then compare them easier? Okay, once you've had to go all of those questions, come on back to see if you were correct. Brilliant. So hopefully you've had a little go at that now. So let's have a little look then. So first thing then, which of these numbers are easier to compare and which ones are more difficult? So first of all, I was looking at them and I noticed straight away that some of them are mixed numbers. So I've got wholes and fractions, and some of them are improper fractions. So I thought straight away, the ones that I thought I could compare were these two here, because they had the same denominator. They were quite nice and easy to compare. Same denominator, so even if they were improper fractions or whole numbers, I would be able to compare them. These ones, all of these ones in general, I thought would be nice and easy to compare just because they simply have their whole numbers. So if this has only got 2 wholes and this has got 3 wholes, I already know straight away that that one is going to be larger than that one because it's got more of those wholes. And then the more difficult thing would be, the wholes would be easy to compare, but then I might have to think a little bit more about the fraction. So here we've got 3 1/4, and here we've got 3 1/2. So then I need to use my fraction knowledge there to say which one is more, which one is less. Again, a more difficult one would always be this one here. Why is that? Because we've got a mixed number and an improper fraction. So to compare any of those, I'm going to have to do a little bit of converting to make sure that they are in the same format. So hopefully you had similar ideas to what I was thinking there. So let's get started then. So 1A, which is closer, the cafe or the shop? So the cafe then, the cafe here is 3 1/4. And the shop is 2 3/4. Now, I would guess straight away that this one is furthest away. It's the longest distance. How do you know that? How do you know? Because I'm simply going to look at my holes. 3 holes is larger and a longer distance than 2 holes. So it doesn't matter what I'm putting it into, even though these are both quarters. So this is nice and easy for me to even draw this because they both have the same denominator. So I've got 1 hole, 2 hole and 1/4. I've got 1, 2, 3/4, sorry, 3 holes and then 1/4. You can see quite easily that this one is the larger mixed number. So this one is the furthest distance away. So the answer to the first one is the cafe. Okay, wonderful. Okay, then next one. So what am I looking at now? It's the beach or the castle. So here, I'm just going to write beach and castle. Not very good. Beach is 2 1/3. Castle is 2 1/2. Now, the first thing I'm going to look at with these two is they both have the same holes. So is that going to help me to compare them? No, because they are the same holes. So now I'm going to have to focus my attention on the fractions. Now, straight away, using your fraction knowledge, you might be able to say straight away which one is larger and why. But I'm going to use my pictorial representations to help me. So let's focus on the beach first then. I've got 2 holes and I've got 1/3. Now, what is the part of this fraction that tells me how many parts make up my whole? It's the denominator. So I know that each of these are split into thirds. I've got 2 whole ones, and then I've got 1 third. Okay, so there's my pictorial representation for that one. This one then, I'm now working in halves. So I've got to split each of my wholes into 2 equal parts, which are halves. I've got 2 whole ones, and then I've got 1 half. So using my representation, I can see here that this one is further away. Oh, it's asking me which is closer. I did not read that question properly, or the last question properly, Miss Sison. I'm always saying to read the question properly, aren't I? So sorry, question A was that the shop was closer because that had the smaller number, the smaller mixed number. And this one, beach and castle, I'm confusing myself now. Closer, smallest distance. The beach is going to be closer because it's the smallest fraction. So that means it's closer to where I want to go. Okay. Now you might have used your knowledge of 1/3 and 1/2, that because that denominator is getting smaller, you knew that that fraction was larger. So 1/2 is greater than 1/3. Okay, so you might have used that knowledge of that little explanation. I do apologise about that one. So 1A then, which is closer, the shop is closer, and the beach is closer. So they might choose to go there because they are a little bit closer. Now, this is where the question is now changing. This is where, Miss Sison, you are now thinking about the furthest one away, which is going to be the largest number. So the garage or the pier. So garage, I've got 3.5. Pier, I've got 13 quarters. Now, straight away, we can see a problem with this. I've got a mixed number and an improper fraction. What am I going to have to do to compare these? I'm going to have to get them into the same medium, the same sort of thing. So either improper fraction or a mixed number. Now, I'm going to use my own knowledge here, and I'm going to think what I am more confident with. And I'm more confident at turning them into improper fractions. Okay, I'm more confident at turning mixed numbers into improper fractions. So I'm going to do that. You might have chosen to do it the other way if you were more confident to converting it to mixed numbers. Okay, so this is where our independent learning is coming in. So now, instead of 3.5, I'm going to convert it into an improper fraction. They are still halves because remember your parts don't change. But now I want to see how many halves do I have. I've got 3 wholes. And I know that each of those wholes have been split into 2. So I've got 6 wholes there, 2, 4, 6. And I've also got this 1 in my half already. So I'm going to add 1 more half. Just remember it's a fraction, not whole numbers. So 6 halves plus 1 half is 7 halves. So there is my improper fraction. Right, can I convert them? Can I compare them now? Because I've got an improper fraction and an improper fraction. Can I compare them? I'm hoping you are all saying no, and you have realised that my denominators are now different. Now, to make them easy to compare, what do we have to try and do? We have to try and get them into the same denominators. Now, I know that the relationship between 2 and 4, that 2 is half of 4 and 4 is double 2. So I'm going to use that knowledge to help me. Now, if I wanted it to be, to put it into halves, I would have to divide 4 by 2 and divide my numerator by 2. But what do I notice about 13? 13 is actually an odd number. So am I going to be able to half that easily to give me an accurate sort of fraction that I can work with? No, because it's an odd number. So I'm not going to be able to half it. So what I'm going to do is I'm going to leave the quarters as they are, and I'm going to convert 7 halves into quarters. So I can actually draw this to help me. So I've got 1, 2, 3, 4, 5, 6, 7 quarters there. 7 halves, sorry. Can you see that? Now I want to convert them into quarters. So I've still got 3.5. I'm now going to turn them into quarters. So this is using my pictorial representation. You might have used our quick way that I'm going to go through in a second. So now you can see my wholes have now all been split into quarters. So let's see how many we would have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Remember that half, we haven't got that half, so we have to ignore that half. So now I have 14 quarters. Let's check it using our rapid method. What has happened from my halves to my quarters? They've got 2 times as many parts, because I've split them all in half. 2 times as many parts. Whatever you do to the bottom, you do to the top. That's going to give me 14. 7 times by 2 is 14. Now I can see which one is, let me check my question properly this time, which one is further away. So I want the larger number. I'm going to use my symbol here to help me. So 14 quarters is greater than 13 quarters. So furthest away is the garage. So well done to you if you got those correct. And obviously you probably will have done that during this question, but you may have challenged yourself to do the other ones as well. Well done. So just while we have got our brains ticking over, and you've done such a great job with that first question, what I'd like you to do is now have a go at these 2 questions here. So you can see they've given you lots of diagrams to help you with this one. So hopefully you should be able to work this out nice and easily. If you did it a different way, or you didn't use those the diagrams there, can you just write a little explain underneath about how you did do it, the knowledge that you use? Because I know that you have got some great strategies now to use when working with fractions. So use them. If you think that there's a quicker way that you could do this, or a more efficient method that you would use it. Okay, ignore the diagrams if you don't need them, but if you do need them, they are there to help you. So 1, Amelia and Max have walked. Who has walked farther? So simply using your knowledge of fractions, all those diagrams there, who has worked farther and how do you know? Question 2, who has more juice? So Jen and Toshi have given you the amounts that they've got. Toshi's got 5.5 litres, but Jen is giving you a little bit of a bit of a brain teaser there. So she said that each carton holds 1/3 of a litre. She has 16 cartons. So you need to work out what she actually has, what Jen has, before you can make your comparisons. That's a bit of a 2-step problem there. And then same again, using, oh, they've already given it you there. Look, they are very kind. They are very kind. I would not have given you that. So then using your greater than, less than, or equal to symbols in those boxes there. But again, I really want you to focus on today how you actually worked it out. So explaining what methods you used or what knowledge you used. So have a go at those 2 and then come on back when you have had a go. Brilliant. So I'm hoping that you've had a little go at that now. So let's just go with this first one here then. So I have walked, so Amelia's walked 1 3/4 miles. I have walked 1.5 miles. So I know straight away I could use this diagram here to see who has walked further. So pink is the Amelia and blue is Matt. So just looking at that diagram there, you can see straight away that 1 3/4 is larger, is greater than 1.5. So I know that I need to use my greater than symbol. So 1 3/4 is greater than 1.5. Okay, so if those diagrams weren't there, or this number line wasn't here, I would then be able to say, well, the ones are the same. They both have 1 whole, so I now need to look at my fractions, and I have got 3/4 and I have got 1/2. Okay, so I know that 1/2 is that much and 3/4 is that much, and using my knowledge I know that 3/4 takes up more of my whole than 1/2 does, because 3/4 is greater than 1/2. There is some knowledge that I would have used. Right, this one here, so 1/3 I've got 16 of them, so I've now got 16 thirds. Okay, you could have used this diagram here, so they very, very kindly giving you the diagrams to colour in. So let's use them. 1, 2, 3, 4, 5, 6, 7 thirds, 8 thirds, 9 thirds, 10 thirds, 11, 12, 13, 14 thirds, 15 thirds, and 16 thirds. That is where my 16 thirds would take me. And Toshi has 5.5. So you can see he's got 1 hole, 2 holes, 3 holes, 4 holes, 5 holes, and 1/2. Now you can see that my 16 thirds finishes there on that hole. This one finishes here, so I can see who has more juice. Let me just check that question. More juice, so I want the larger number. Toshi has got the larger number, so 16 thirds is less than. So I need to remember that my smaller side, when I see the smaller side, I say less than 5.5. Now, what I'm going to do there is I could have double checked my answer using my conversion. So you can see here, this was 5.5 is a mixed number. This one was 1, 2, 3, 4, 5, and 1/3. So I've used that to turn them both into a mixed number. So 5 and 1/3, 5 and 1/2. We already know that the denominator, the smaller the denominator, the larger the parts. So if I've got 1/2, I'm only cutting that whole into 2 parts, whereas this one I'm cutting it into 3. So 1/3 is less, a smaller part than 1/2. So I know that 5.5 would be greater. So well done to you if you got those, and make sure you're sending all of these great explanations that you are doing to your teachers on portfolio. So even if that's drawing them or writing them, or you could even send us a little explanation if you want to. You can do videos on portfolio. We would love to see those. So I'm hoping now that all of your strategies and all of your ideas have been coming together, and you've been talking through all of the great ways that you can compare these fractions. Okay, so what I would like you to do now is to have a little go at your practice book challenges. So here you can see question 1. We're going to be using this number line, which we did yesterday. So you're going to put your mixed numbers onto this number line. Now be careful. Look at what your number line is going up in. Okay, there's 1, 2, 3, 4 parts. There's 4 parts in that number line. So each of these small parts must represent a quarter. Okay, and just be careful because one of them is a half. So using your knowledge of equivalent fractions, you should be able to plot those onto your number line. Once you've done them, can you then put those 4 into order from the smallest to the greatest? Okay, so the smallest to the greatest, ascending order. Fabulous. Once you've done that, question 2 is simply asking you to just circle the ones that represent the largest number. Okay, so this one or this one, which one is larger? This one or this one, which one is larger? This one or this one? Be careful with this one because they are different fractions. So just make sure that you use your knowledge of those fractions to help you. Simply, question 3, you're just using your greater than or less than. So if you need to do any working out, I don't think too many of those are nasty. You can see that they are all the same denominators, so there's no equivalent fraction you have to use, but some of them you will have to convert to mixed numbers or to improper fractions. Okay, you are all confident and all great at that, and if you do need to go back, remember in your books you should have written the steps to take from last half term to convert from mixed numbers to improper fractions or improper fractions to mixed numbers. So always refer back to that if you need to. Wonderful. Question 4 then. Who has cycled farther? So they've given you some diagrams to fill in to help you. You want to show Kate 5 3/4, and then Lee 5 3/8. So just look at that. You've got different denominators. So what are you going to have to do to Lee's to see who has cycled further? And as always, once you've done that, oh, no, sorry, there's another question. I forgot about this one. So this one again is just referring back to using your knowledge of equivalent fractions to make sure that you can use and turn them into the same denominators. Okay, so remember, same denominator helps you to compare them. So use your knowledge of equivalent fractions to get them into the same knowledge, your knowledge of multiples to tell me which is greater than, which is less than. Okay. So you've got all the way up from A to L there. So that one will keep you very, very busy. And if your brain is still raring for more and it's not sort of lost its will a little bit with all of those questions, because there's lots of questions today, there's always the challenge for you to have a go at. If that challenge is a little bit too tricky and you think, I'm not quite ready for that yet, remember that keyword yet, you can always have a little go at your explain it, and then come on back to your challenge maybe over the weekend if you are wanting to say, do you know what, I'm ready for that challenge now, I'm ready to have a little go at it. So reflect then, everybody, I would like you to have a go at it. Explain 2 different methods for comparing 8/3 and 2 1/6. So what could you do? And I'm giving you a little clue up here. I hope you have a wonderful, wonderful weekend, and I look forward to seeing you with your learning next week. And I look forward to seeing all of these great explanations, because you are absolutely smashing your fraction learning and you should be so, so proud of yourself. I will see you all again soon. Goodbye.